Let's talk today about reinforcement learning and just what it is in general, which I guess we should cover in a course on reinforcement learning. Again, watching this video is not mandatory, and it will be a little bit shorter than the usual videos because we have also other activities in the third class. Okay, so there are different types of learning, and the first, maybe most well-known one is so-called supervised learning. In supervised learning, we have a data and a label, and then we train on the data with the labels. And then later on, after we trained, we give some new data to the computer, and it tries to create the label. So that's a very well-defined task, and it's very clear what is to do and how to. Well, it's unclear how to do it, but we can measure how good we are actually. And let me give an example. So you give some pictures maybe, and you say, oh, well, these on the left there are horses, on the right are pigs, and then later on, so you train on those, and then later on you get this picture, and then you have to figure out whether it's a horse or a pig. That would be a classical supervised learning task. Already more complicated is the unsupervised learning task. So you've given some data, and then you should make sense out of it. So the problem here is it's not even clear what does it mean to make sense out of it. But to give an example, so we have given some horses, and then you may recognize, oh, actually we figure out there's these black horses and these white horses. So they seem to form two different categories. And in certain settings, we may boil down more accurately what we want. But in general, in unsupervised learning, the task ahead is not so clear. And we are clear in the disadvantage because we don't have labels for our data, or we may want to find some structure. It's not quite clear how to do this or what exactly the goal should be in unsupervised learning. Now, in reinforcement learning, the situation gets even more obscure. So we have some agent that should interact with the world and then get some information about the world, and it gets some rewards. And then the aim is to maximize this reward. So somehow we have some elements of supervised learning, which is we know when a situation is good because we get some reward which says it's good or not good. So similar to in supervised learning, but similarly maybe to unsupervised learning is we don't even know this world, right? We don't know where to go in this world or what to do, and so we're somewhere in this world. And to translate it to horses is like you're suddenly a horse and you run around this world, and somewhere is a reward, but you don't even know where. Now, for reinforcement learning in games, the situation becomes even more complicated because there's this agent that you control, which is in this world, and then you get some feedback on this world. But there's also this other agent which also interacts with this world, that also wants to get some information out of it. And it's not just this world that you interact with, it's this other agent that you interact with veers this world, and that makes it really tricky. Because this agent, for you, it's kind of part of the world, but it does adversarially react towards you. So you not just need to understand this world, you also need to understand that other agent. And that other agent you may not have access to even. So to translate it to this horse language is there's another horse that also tries to capture the reward, and it may not be acting nicely towards you. Okay, the first assignment will be in class. Try to think of these different tasks here and try to think which of these categories, the four categories that are presented, you would put in each of those tasks. Note that there's not necessarily a correct or wrong answer. And then once you did this, you may notice that you feel that maybe some of this task you would put into the category of supervised or unsupervised learning. So you could think of that, let's say I've been able to solve the supervised learning task. How does it help me in reinforcement learning, right? And then once you thought about this, the next question comes, okay, I've now thought about, I know how supervised learning helps, and assume we have like enough machinery to solve the supervised learning task. What does remain in the reinforcement learning? What is really, what's the challenge there? Then, assuming we can solve the supervised learning task. Okay, so let give me some elements of supervised learning or reinforcement learning. Oh, sorry, you will post your answer in Teams. So there is an agent. This is kind of a vocabulary, and there is an environment or world. Oh yeah, sorry. Here, I want to put the bandit agent, the bandit problem, also into this framework where the world is very static. We are always at the same location in the world, and we can only interact with the world with having these four these k options, and then we get reward. So the k-arm bandit problem is like a simplistic or simplest model of reinforcement learning. So we have usually a world or an environment in AI for games or in reinforcement learning for games. Usually the computer game is my environment. One of the typical problems in reinforcement learning is that you have a delayed reward. So you do some action, then something happened in the game, and only much later you see, well, you get some reward and it's positive or negative. This makes learning very difficult. So this is a delayed problem. There may be a lot of different states. So here we have only a finite number of states and we have full information. In general, there could be a huge number of states, also a huge number of actions that are possible, or even a continuous number of states and actions that we need to deal with. So for instance, here in Go, we have a finite number of actions, but for StarCraft, we have an infinite number of actions. You may encounter the situation that you have full information or you have hidden information where you don't know everything about the world or even just about the current state. For instance, in Go, you have full information. Let's say in this bandit agent problem, you don't know these probability distributions. So it's kind of questionable whether this would be full information or not, because there aren't really changes of state. And in StarCraft, obviously there's a lot of hidden information, and somehow this is a major obstacle that you need to scout and have to manage also the amount of information that you want to have. So one thing that is also very important is in reinforcement learning, if you do an action, you're not just changing your position in the world, you're also changing the world by itself. So this is not the case in the k-arm bandit problem, so that's why it's very simplistic. For instance, in Go, obviously you change the way the board is, and that changes what future actions are possible. So you do an action, and then you want to look for the reward, but you want to also look for what will be the expected reward over time. That's the value of an action. Worlds can be probabilistic or deterministic. So this could mean that you don't know that you do an action, and sometimes something happens, and sometimes something else happens. Or in the deterministic world, that would be easier. Always the same thing happens. Okay, so just to get you familiar with these basic terms in assignment 2, I want you to consider these 5 games: Tetris, PUBG, Age of Empires, Among Us, and Go, and then categorize along these dimensions where you would put each of those games. So how much hidden information are there, or is it full information games? Are rewards immediate or they're very delayed? Or Regarding states, is there an infinite number of states, or is there just few states? Um, Regarding the actions, how many possible actions are there? Infinite or few? The same with complexity. So I haven't mentioned this, but I think it's pretty straightforward. And yeah, then is a world probabilistic or deterministic. Okay, that's it.